This is lecture number 08. So we'll discuss about the collision. What is a collision? We have already seen there is a game, carom board. Have you seen? I think most of you have already played that game, and you have seen already the billiard game. In carom board, what happened? There is a one mass is collide to the other mass, and that move in different places. So this type of phenomena is called collision. How many type of collision? There is a two type of collision. One is one dimensional and two dimensional. For example, 1D and 2D. This is 1D and 2 dimension. In one dimensional collision is also called head-on collision, and two dimensional is called oblique collision. Which type of it is? Head-on. Head-on, and this is called oblique collision. Oblique collision. Now, what is the difference between head-on and oblique collision? In head-on collision, suppose one mass m1 and another is m2. After collision, the direction of motion after the collision is in same straight line. Then that type of collision is called head-on collision. Before collision, it was also moving in this direction. This is a straight line. This is line of impact, and the motion of the direction and line of impact in same. After the collision, post collision, it's also the same. That type of collision is called head-on collision. In other hand, if before collision it slightly collide in angle inside, not in the center of the mass, inside, then what happened? After the collision, both will move in different direction, not in a straight line. So that type of collision is called oblique collision. Again, whether it is one divided again in three categories. One is called elastic collision. Another is called inelastic collision. And third one is perfectly inelastic collision. These are the three categories of collision. So we will discuss one by one. What is the difference? First, we must understand in all three categories, linear momentum conserved. So now onward, I will talk only momentum. I will not talk linear. Momentum in the sense linear momentum. Momentum is conserved. What does it mean? That suppose this is a mass m1 and m2. Initially it is moving with initial velocity u1 and u2. When will it collide? If u1 is greater than u2, then will only collide. Otherwise only separation will be there. Okay. Suppose u1 is greater than u2, then it will come closer, approach closer. Once it collide will happen. Here collision will happen. In the collision there may be deformation, and after the deformation again it will separate, and this is a b1 and b2. In the case of separation, the b2 will be the greater than b1, then will separate. Okay. So m1 u1 m2 u2 b1 m1 will be the same because mass will not change. In this case, this is the phenomena of collision. In this case, what happened? The linear momentum is conserved throughout the journey. What happened? Linear momentum, the momentum is conserved throughout the journey. In the sense, before collision, during collision, this is called during collision, and post collision, after collision. This happened for every three cases: elastic collision, inelastic, and perfectly inelastic collision. But the kinetic energy will conserved only in the case of elastic collision, but in inelastic and perfectly inelastic it will not happen. So what is the major difference between both three? That linear momentum p equal conserved, the condition 1, and for this also p conserved, p is denoted by the linear momentum and p is conserved in all three cases. Conserved in the sense that initial momentum equal final momentum. But in the case of elastic collision, kinetic energy initial equal kinetic energy final. It's happened. That means it doesn't mean that kinetic energy lost. Kinetic energy lost during the deformation, but it is regained. The lost is regained, and in initial condition the kinetic energy how much, and the same is in the final condition, but not during the condition, during the collision. In the case of momentum, during the collision it is also conserved, but not in the case of kinetic energy. So sometimes this may question asks that the kinetic energy is conserved throughout the journey. It doesn't happen. Only kinetic energy initial and kinetic energy final, that is the equal. If I want to show in graph, so what it would be, suppose this is the energy, this is the time, and this is the P. In the PE, it is throughout the journey is constant, that is it doesn't change. Achha, the kinetic energy and potential, the kinetic energy and the momentum, whatever I am talking, that is the system, about the system. It doesn't mean that individual of momentum and individual kinetic energy is not conserved. Only the conserved is happened for the system, that is m1 u1 plus m2 u2 well, initial momentum, and m1 v1 plus m2 v2, that is called final momentum of the system. So not individual. This happens. This is the P and T and a constant. And in the case of kinetic energy along with time, so kinetic energy initial is same, and there is a loss in the collision, and final is same. Initial is same and final is same, but in between there is a lost due to the deformation. And this happen is in the elastic collision. So what is the condition? That P is conserved and kinetic energy and kinetic energy initial for the total system for the both is equal to the kinetic energy final for both. And come to the inelastic collision. In elastic collision only P is conserved, kinetic energy initial will be the greater of kinetic, because there is a loss of kinetic energy during the deformation. It will not totally regain after the collision. And perfectly inelastic, that is a special condition of inelastic condition. It is a part of inelastic that P will conserve, but the kinetic energy will not conserve. But what happened after the collision? So both will come together, stick together and move together. Then M1 and M2 became the will contact. So we will study one by one. First come to the inelastic collision. So pause the video. Now we are going to study about the one dimension elastic collision. It is also called head-on collision. So this we will study. Suppose there is a two balls. One is mass m1. This is a mass m1 and initial velocity u1. Another is mass m2. Initial velocity u2, and here u1 is greater than u2. And there will be the collision. And this is the case of after collision. After collision mass will be the same m1 m2 and velocity suppose b1 and b2. Here we will talk b1 is a final velocity and this is a elastic collision. So what is the aim of us? This is known categories, m1 and m2 we know, u1 and u2 we know, but we don't know b1 and b2. So since there is a condition, we apply the condition and we will try to find out the velocity b1 and b2, that is unknown quantities. Correct? Okay. For elastic collision, what is the two condition? One is kinetic energy initial of the system is equal to the kinetic energy final, and momentum is also conserved. So what will be the initial momentum in this case? m1 u1 plus m2 u2. This is the momentum of system. This is the total momentum before collision is equal to the total momentum after collision. Why I am doing so? Because m1 we can this is identical, that's why I am doing so. m2 b2 minus m2 u2, and now we can m1 u1 minus b1 common that m2, that is b2 minus u2. So this is the equation number 1. And another condition is kinetic energy initial of the system is equal kinetic energy final. So condition 2 applying. This is the condition, P initial equal P final. Now kinetic energy initial equal kinetic energy final. What will be the half m1 u1 square plus half m2 u2 square equal half m1 b1 square plus half m2 b2 square. Correct? This is the condition. Second condition, you can rewrite the equation m1 u1 square plus m2 u2 square equal m1 b1 square plus m2 b2 square. Now common m1 u1 square minus m1 b1 square equal m2 b2 square minus m2 u2 square. Correct? Okay, come here, because since there is no place, common the m1 in left side, that is m1 e1 square minus b1 square, m1 common, so e1 square minus b1 square, and in right side that is m2 common. So here m2 is common, b2 square minus u2 square, b2 square minus u2 square. So m1 e1 square minus b1 square, do you know a square minus b square, a plus b into a minus b, there is a formula. So you can rewrite e1 plus b1 into e1 minus b1, same happen b2 minus u2 into b2 plus u2. So this is the equation number 2. If we divide the equation number 2 with equation number 1, so what happen we will see. Divide by equation 2 by equation 1 in left hand side. What is the equation 2 that, and equation 1 is this. So first let me write equation 1, m1 u1 plus b1 into u1 minus b1 divided by m1 u1 minus b1, m1 u1 minus b1, and in right side m2 b2 minus u2 into b2 plus u2 divided by m2 b2 minus u2, b2 minus e2. So look at m1 will be the cancel, and u1 minus b1 u1 minus b1 cancel, same happen here. So we will get in left side what is left, that is u1 plus b1 equal u2 plus b2. So what is required to be find out, what are the unknown b1 and b2. So we will first write this equation. This is the equation number 3. So b1 equal u2 plus b2 minus u1, and if we want to say b2, then u1 plus b1 minus u2. So this equation, look, this is a known quantity, but there is an unknown quantity. So we cannot find out with this b1 and b2. For this, the same value we will put to the equation number here for this equation, that is a star equation. So we will find out the b1 and b2 in the terms of u1, u2, m1, m2, since m1, m2 and u1 and u2 are known to us. Understood? Pause the video and note it down, then we will again start from here. Now put the value of b1 to the equation of star, get it. In left side m1 u1 plus m2 m2, in right side m1, in the place of b1 what we will write, u2 plus b2 minus u1. So put it u2 plus b2 minus u1 plus next term is m2 b2. Is it correct? Okay. Now let's go. there is a m1 u1 plus m2 u2, m1 u2 plus m1 v2 minus m1 u1 plus m2 v2. Now our target is to find out the b2 because in this equation only b2 is unknown quantities. m1 u1 and there is a m1 u1, so let it become here, since there is a minus it will come here, plus m1 u1 plus m1 u1, and there is a m2 u2 and here is minus m1 u2 equal common b2 is common and rest it will be m1 plus m2, correct? Get it? Okay. So m1, this is same quantity, so it will be 2 m1 u1 plus, since u2 is the same, so we can take a common u2, m2 minus m1 equal v2 m1 plus m2. Hope you have already noted it down. So may I clean? Okay. I am cleaning only this portion. We require to find out the v2. So let assume that this is in left hand and that is in right hand. So v2 equal, in right side, m2 minus m1 divided by, it will go for divide, m1 plus m2 into u2 plus 2 into m1 divided by m1 plus m2 into u1. This is the formula to find out the b2. In this way we can find out the b1 as well. So how can we find out? We have put the value in place of b1 to find out the value of b2. If we put the value b2 in to find out, we can easily find out the b1. So how can we remember this? And this is very much important and we must remember it. How can we remember? Look at, there is a b2 is dominant, understood? So since there is a b2, so it will be the u2 and it will be the u1 and rest b2, so m2 will be the come first, m2 minus m1, m1 plus m2, send 2 into m1, since we have the this will be the dominant and this term will be the u1 and m1. Same condition, same logic, similarly we can write about the b1 also without calculating. How will it be? I am erasing this one also. b1, since b1 is dominant, so m1 minus m2 will be there, m1 minus b1, m1 is dominating and here will be the same, m1 plus m2, and this here it is u2, since there is a b2 and there is a b1, so it will be u1 plus 2 into, here is m1 but it will be the m2 and rest is same, m1 plus m2, this is 2, since it is 2. So this is the value of b1 and b2. And in right side, look, u1 we know, u2 we know, mass we know. So known quantity in right side and unknown quantity is left side. This is the derivative of finding the b1 and b2. So we can easily find out these are the values. So rest we will study, and this equation is valid only for whom? For the elastic, because we have applied two conditions. One is linear momentum is conserved, another is kinetic energy is conserved. But in the case of inelastic and perfectly inelastic, we cannot use this because the condition is different. Understood? So next we will study about the special cases of elastic condition. So what type of special condition will be? First, the masses will be the identical. Second, one mass will dominate other. Dominate in the sense m1 will be the greater, very greater than m2, and m2 will be the very greater than m1. Third condition. And in all three conditions we will study. Okay, this will be the special cases. First, we should understand all these terms and how does it find out. Get it? And remember this one. In physics, generally we told that no need to remember that concept we should know, but in this case we should remember because we will not get so much time. The formula should be, although the formula is concept based, to get it. So there is a requirement, a number of calculations are there. Since there is a number of calculations, so it may be out from the mind. For this reason, we have to remember this one. So B2, U2, B1, E1, these are the B2, M2, B1, M1, B2, that is opposite E1, B1, opposite U2, and rest are same. We can write the equation number 3 in this way. E1 plus B1, so E1 minus U2. Can we write? E1 minus U2, yes, and B2 minus B1. What does it mean? This is the relative velocity before collision and relative velocity after collision, post collision. In before collision, the relative velocity is called velocity of approach. Here U1 is greater than U2. It is coming together. Until it doesn't come together, so collision will not occur. That's why it is called velocity of approach. And this is velocity of separation. After collision, there is a separation occurs. So hence, we will talk, this is called velocity of separation. And this happens only in the case of elastic collision. In elastic collision, velocity of approach is equal to the velocity of separation, or the relative velocity before collision is equal to the relative velocity of after collision. One more quantity we will study about, that is coefficient of restitution. Coefficient of restitution. What does it mean? This is the ratio. किस चीज का ratio? This is the ratio of velocity of separation to velocity of approach. यानी कि velocity, this equal velocity of separation B2 minus B1 divided by velocity of approach U1 minus U2. There is one thing is, have you noticed that velocity of separation, that is B2 minus B1, and velocity of approach U1 minus U2. That is why it is not U2 minus U1, since U1 is greater than U2. U1 is greater than U2, hence U1 minus U2, and this is B2 will be the greater than B1. There is separation. That's why B2 minus B1. Get it? Okay, very nice. This is denoted by E. So E is the ratio of B2 minus B1, that is relative velocity of after collision to the relative velocity before collision, that is the ratio. And in the case of here, how much value will be the E? Here in the sense elastic collision, since this is equal, hence E equal will 1, this value and this value is equal, so it will cut it down and E will be the 1. In the case of elastic collision, the value of coefficient of restitution, which is denoted by E, equal 1. And in the case of inelastic collision, since there is a loss of kinetic energy, so velocity will be decreased, relative velocity will be decreased, and denominator will be more than the numerator, hence the value will be less than 1 but greater than 0. In the case of perfectly inelastic, I'm talking, in the case of perfectly inelastic, E will be the 0. So here E equal 1. In the case of inelastic, the value of E will be in between 0 to 1, and in the case of perfectly inelastic, the value of E will be the 0. This is called perfectly inelastic. These are all 1D collision or head-on-head collision. So do remember this formula. This is very important formula, that is B2 and B1, as well as the coefficient of restitution. What is the value of, if anywhere there is written the value of coefficient of restitution is 1 and nowhere is given about the collision is elastic or what type of collision. So we should consider that is elastic condition. Why? In only elastic condition the value of E is 1. Understood? If there is a kinetic energy conserved, then again we can say, if there is a kinetic energy conserved, that means we can say this is elastic. If there is elastic, then along with the momentum, the kinetic energy will be conserved and the value of E will be 1. And this condition, the velocity of approach is equal to the velocity of separation. We can write it down. Okay, so note it down and do practice. Next video we will do some numerical on the basis of this, and numerical will be based on PYQ, that is previous year question of NEET IIT Advanced. Understood? Okay, so that we can better use this concept